Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 4. We'll be discussing the topic Center of Gravity and Uniform Circular Motion. In the previous class, we have already started this chapter and discussed the topic related to torque. Hope you all have watched that video. If you haven't watched, go watch that video first and come to this video. Are you ready? Let's start. Our first topic for today is center of gravity. Center of gravity is a word we all are familiar with. In our day-to-day life, we come across many instances where the word center of gravity is being used. We know that Earth pulls every object towards its center with a force of gravity. Okay, there is a force of gravity with which Earth pulls every object towards its center. Okay, and this force of gravity helps us to stay stable on the surface of Earth. We all know this, right? Now, what is weight? What is weight of a body? Weight is the force with which Earth pulls an object. For example, when I stand on a weighing machine, is it actually my mass or weight? It is a weight, that is my mass into acceleration due to gravity. Weight is equal to mass into acceleration due to gravity. And weight is a force with which every object is attracted towards the center of Earth. Okay, what is the unit of weight? We know that weight is a force. Unit of force is Newton. Yes, therefore the unit of weight is also Newton. So when you stand on a weighing machine, it is actually the force with which Earth is attracting. It is a force that is given. Okay, now consider a body. Here this body will be made up of many tiny particles. Let us say first particle with weight W1. Second with weight W2, then W3, W4, W5, W6. We know that weight is a force which is acting downwards. Each of this weight, these forces will be acting downwards. Okay, which means these forces are parallel to each other. These weights are parallel to each other. W1 parallel to W2, parallel to W3, parallel to W4, parallel to W5, parallel to W6. Okay. Now, how to get the total weight of this body? What is the total weight? Total weight will be equal to capital W is W1 plus W2 plus W3 plus W4 plus W5 plus W6. Now, where is this total weight of the body concentrated? Okay, the point where the total weight is concentrated is the center of gravity. Okay, total weight W. Let us say here is the center of gravity of the body. Then total weight W will be acting downwards on this point. Clear? Now we know that here because of this weight and distance from a point when taken, that is the center of gravity, you will be having or be able to calculate the moments. There will be anti-clockwise moments and clockwise moments. Now if I am considering a point here, the perpendicular distance you will be getting and you know the force. Now what is torque or moment of force? The product of force and the perpendicular distance. So in each case, for W1 you will have a moment, let us say M1. M1 will be equal to W1 and this distance is taken as R1. Okay, W1 R1. What is M2? M2 will be W2 R2. M3 W3 R3. M4 W4 R4. M5 W5 R5 and M6 is W6 R6. Okay, this is the distance R2, this is R3, R4, R5, R6. Okay, now what happens when you take the algebraic sum of this? Here W1, here we have the point, which means this rotation when taken, it will be showing anti-clockwise. Okay, here the moment is anti-clockwise moment. For W1, W2 and W3, we have anti-clockwise moment, which means M1, M2 and M3 will be taken positive. We know that anti-clockwise moment is always taken positive. What about W4, W5, W6? The moment due to these weights. They will be in the clockwise motion, which means we will be having clockwise moments. They will be taken as negative. Okay. Therefore, M4, M5 and M6 are negative. Now take the algebraic sum of this. Adding, you will be getting total moment. Okay. Algebraic sum will be equal to M1 plus M2 plus M3 plus M4 plus M5 plus M6. Okay. That is W1R1 plus W2R2 plus W3R3 minus W4R4 minus W5R5 minus W6R6. Okay, when you take the algebraic sum of this, you will be getting this equal to 0. Okay, that is where we have considered a point. With respect to a point, we have taken R1, R2, R3, etc. Right? So, we can define the point of a body about which the algebraic sum of moments of weights of all particles constituting the body is 0 is the center of gravity. Understood? Here we have considered a point. Okay. Distance of these weights from the points are taken as R1, R2, R3, etc. Okay. When you calculate the moment and take the algebraic sum, then the algebraic sum will be equal to 0 with respect to that point only, and that point is the center of gravity. Okay. Entire weight of the body will be acting at this point. When you consider the case of a scale, okay, let us say this is a 30 centimeter scale. At 15 centimeter, let's say at the midpoint, 15 centimeter, if we have the center of gravity and we consider two particles here. Okay, this is the first particle W1, this is the second particle W2. Here you will be having the anti-clockwise moment which is in this direction. Here you will be having clockwise moment in this direction. Distance will be same. Okay, here 15 centimeter, here 15 centimeter. Let us take it as L because both of these distances are same. Okay, it is a scale of length 2L, each part will be L. Now, since this is a uniform body, weight, the particles will be similar and the weight of particles should be same. Therefore, W1 will be equal to W2. When you take the moment, here you will be having W1 L and this will be W2 L. Since this is clockwise, you will take it as negative W2 L. When you take the algebraic sum, what you will be getting? You should be getting 0. You will be getting 0 because W1 will be equal to W2, similar particles. We know L and L are equal the length. Okay. Therefore, when you take the algebraic sum, you are getting equal to 0. Fine. We have three important points related to center of gravity. The first one is the position of the center of gravity of a body of given mass depends on its shape, that is on the distribution of mass of particles in it. It changes if the body is deformed. Now consider the case of a metallic wire. Here I have taken a metallic wire. This is a straight wire. Where does the center of gravity lie? Almost at the center. If it is a 10 centimeter long wire, then at 5 centimeter you will be having the center of gravity. When the same wire is bent into the shape of a circular ring, you know what happens? Then the center of gravity changes. That is, when the shape of an object changes or the shape is deformed, what happens to the body? The center of gravity will also change. Here we had center of gravity at the center of this metallic wire. If it is a 10 centimeter wire, then at 5 centimeter point you will be having the center of gravity. But when it comes to the ring, that is the same wire is made in the form of a ring, what happens? The center of gravity will be at the center of circle and this point is an imaginary point. Okay. This is an imaginary point. The center of gravity does not actually lie on the body. It is at an imaginary point which is inside the circle. Understood? So, when the body is deformed, what happens to the center of gravity? The center of gravity will also change. With the same wire, if I am making some other shape, I am constructing a triangle. What happens? Again, the center of gravity changes. Okay? So, this is your first point. Now, the second point, it is not necessary that the center of gravity always be within the material of the body. Consider the same example. We took a metallic wire. We said that the metallic wire had its center of gravity almost at the center of the wire. The center of gravity is lying on the surface of this metallic wire. But when this body was deformed, when the shape of this body was changed, it is made into a ring. What happens? Center of gravity is at a point inside this circle, inside this ring. Okay, so it is not necessary that the center of gravity will always lie on this body. It can lie inside or outside the body. Okay, it is here. In this case, it is in an imaginary space. Only important point to be noted is that when you take the algebraic sum of the moments, it should be equal to 0. Okay, when you have center of gravity here, you will be having a particle here, you will be having a particle here. Consider this is W1, W2. Particle, first particle has a weight W1, second particle has a weight W2. Now, this distance is some L1, this distance is L2. Okay. So, from the center of gravity, there will be this W1 is a force, W2 is also a force. Okay. Now, we can experience a torque or moment. How to calculate the moment? We will just take the product of the perpendicular distance and the force. Here the force is W1 and W2. When you take the algebraic sum, here you will be getting a anti-clockwise moment and here you will be getting a clockwise moment. When you take the algebraic sum, since the weight will be equal because here we have a uniform rod, all the particles will be having similar weights. Okay, and this point is the center. Here, if you are taking a 10 centimeter long wire, then 5 centimeter, 5 centimeter. L1 and L2 will also be equal. So, when you take the algebraic sum, what happens? A moment, the sum of the algebraic sum of the moment will become equal to 0. When you take this case, here, if you are considering this is a point of center of gravity and consider two particles. This is your first particle, this is your second particle. Okay. Weight W1, here again weight W2. Now, this is a perpendicular distance. Yes, this is a perpendicular distance from the center of gravity, line of action of force. So, here you will be having L1. Okay, this is L2. In this case, in which direction do we have the moment? You will be having anti-clockwise moment and the weight W2 will have clockwise moment. When you take the algebraic sum again, you will be getting the algebraic sum equal to 0. Okay. So, this is your second point. Now, the third point, by the concept of center of gravity, a body of weight W can be considered as a point particle of weight W at its center of gravity. As we said, if you are considering a body, this is your body, okay, we'll be having many particles. This is W1, this is particle of weight W2, here W3, W4, W5, etc. Okay, so you have many particles and all these particles have different weights. Now, when you take the concept of center of gravity, this body of weight W can be considered, this total body can be considered as a tiny particle of weight W. Okay, it contains many particles, yes, and this body can be considered when you know the center of gravity. So, with respect to the center of gravity, we can say that this particle is a tiny particle with weight W. So, this is your third point. Okay. Next, we are going to see the center of gravity of some regular uniform object. We have some objects here. The first one is a rod. For this metallic rod or a metallic wire, how do we find the center of gravity? How to find the center of gravity? As I said, if this is a 10 centimeter long rod, then the center of gravity will be at the midpoint of it, that is at 5 centimeter. Okay. So, for a uniform rod, when taken, center of gravity will be at the midpoint. Now, we have the ring. For a circular ring, where do we have center of gravity? For this circular ring, center of gravity will be at the center of the circle. Okay, at the center of the circle, you will be having center of gravity. Now, what is this? This is a circular disc. Okay, here this is a hollow ring. Here it is completely covered. So, it becomes a circular disc. Same as in case of circular ring. Here the center of gravity will be at the center of the circle. What is the difference? Here center of gravity, in case of a ring, center of gravity will be lying on a at a point, that is in the imaginary surface. Okay, it is not on the body. But when it comes to circular disc, center of gravity is a point on the object. Okay. Next, fourth one, we have a triangular lamina. In this case, how to find center of gravity? Let's see. First, we have to draw medians to this. Okay, how to draw a median? What is a median? A median is a line which is drawn from one vertex to the opposite side. Okay, this is my first vertex. I am drawing a line to the midpoint of this side. Okay, this is my first median. Now the second median, from this vertex to the midpoint of this side, and from this vertex to the midpoint of this side. I got 3 medians now. Now all these 3 medians will be meeting at a point. Yes, this is the point, and here the required center of gravity of triangular lamina is at the intersection, the point of intersection of all these 3 medians. Okay, next we have a rectangular lamina. Now check this. Here, in order to find the center of gravity, what you have to do is, you have to draw the diagonals. How to draw diagonals? From one end to the opposite end. Draw a line. Similarly, from this end to this opposite end, draw a line. So, these are the required diagonals. Now, these diagonals will intersect at a point. Yes, so this is the point of intersection, and this point is the required center of gravity for a rectangular lamina. Similarly, in the case of a square, same thing. Square is a rectangle with all the sides equal. Yes, again draw the required diagonals. They meet at a point, and this point is your center of gravity. Now come to the case of a parallelogram. Parallelogram, draw the required diagonals. Here we have diagonals. Okay, they will be meeting at a point. This is your center of gravity. Next we have a cylinder. How to find the center of gravity of a cylinder? Center of gravity of a cylinder will be at the midpoint of the axis of the cylinder. Now how to find the axis of cylinder? Here the cylinder will be having a base and the top. Okay, they will be circles. For the circles, you will have centers. Okay, when you join these centers, you will get the axis of the cylinder, and midpoint of this axis will give you the required center of gravity. Clear? Next, when you have a sphere, in case of sphere again, you have to find the center of the sphere. If you cut the sphere into half, you will be getting hemispheres. Okay, this hemisphere base will be having a center. This center is the center in case of a sphere. Okay, center of gravity for a sphere is this center. Next, we have the case of solid cone and hollow cone. Hollow cone means it is an open cone. In case of a solid cone, we can find the center of gravity. It will be equal to here. This is the total height of the cone. Okay, height is taken as h. Then center of gravity will be at a height h by 4 from base. Okay, this is your base. From base, you have to measure h by 4. At that point, you will be getting the center of gravity for a solid cone. Now, when it comes to a hollow cone, to find the center of gravity, this is the required height. Then h by 3. Height by 3. You have to measure from the base. Okay, from the base, by measuring h by 3, you will be getting the center of gravity. H by 3 from base. Got it? So, we have determined how to find the center of gravity of some regular uniform objects. Okay, we can tabulate the center of gravity of some regular uniform objects. First is the road. For a road, center of gravity is at the midpoint of the road. Second, circular disc, it is at the geometric center. Next, a hollow or a solid sphere, it is at the geometric center of the sphere. Next, solid or hollow cylinder, where do we have the center of gravity? It is at the midpoint on the axis of cylinder, as I have shown it. Next, solid cone. For a solid cone, at a height h by 4 from the base on its axis. Next, a hollow cone at a height h by 3 from the base on its axis. For a circular ring, where is it? At the center of ring. Triangular laminar or a scalene triangle, where do we have the point of intersection of the medians, where the medians intersect. Next, a parallelogram, rectangular lamina or a square or rhombus. In any of these cases, the point of intersection of the diagonals. We will draw the diagonals and find the center of gravity. Clear? Next, the center of gravity and the balance point. What is a balance point? Here you can see a body is supported with this. Okay, what is happening? The body is oscillating. So when this is adjusted at a point, what happens? This body will come to horizontal. Okay, and that point is called the balance point. When you have a road, okay, this is a uniform road or a meter rule. Meter rule means 1 meter is 100 centimeter. We have a meter rule of 100 centimeter. At 50 centimeter, that is at the midpoint, if you keep a knife edge, what happens? By keeping a knife edge at this point, it will be balanced. Okay, that is equal distance from both these ends. It will be balanced. Now, if I need to balance this pen, what will I have to do? I'll keep my fingers at different points and check if it is balanced or not. Okay, if the pen falls, then it is not balanced. I have to find a point where the pen doesn't fall. Okay, so this is somewhere the point is where I can balance. Now I will be taking a book and trying to balance the book. Okay, book is in the shape of a rectangle. So by drawing a diagonal, both diagonals should be drawn, and at the point where they intersect, you will be getting the center of gravity. So here I have a book and I am going to balance this. Let's see how to balance this book. Okay. So keeping my finger here at this point, I think this is a point where the diagonals will intersect. I can balance the book. Okay, I can keep the book like this, right? So this is the center of gravity. If I try to keep the book here somewhere on my finger, the book is falling, which means it is not the balance point. So you will be having a balance point which will be at the center of gravity. Only at that point you can balance the body. So initially when you suspend it, what happens? It will be oscillating. For example, you are taking a body, okay, putting a hole on it and trying to suspend it with a support. So what happens? Initially it will be oscillating for some time, and after that what happens? It will come to rest. Okay, and this axis, that is this, it is hung over a string. You can see this, right? When you extend the string, you will be getting a line of force, and the center of gravity of the body will be lying along the line of force. Okay. Next, we have a simple experiment to determine the center of gravity of a body. Okay, for an irregular body. Now, consider an irregular body. Okay, to find the center of gravity, what we are going to do is, we are going to put 3 holes on this body. Okay, this is A, this is B, and this is C. Now, what I am going to do is, with taking this hole A, I am going to hang it on a string with some support. So here, this is point A and I have hung with this hole. Now, extending this line of action, what happens? I'll be getting a straight line, and then we can say that center of gravity will be lying on any of these points. Okay, any point on this line of force. Now, next what we have to do is, you will be drawing a straight line on this body. Next what you are going to do is, let us mark this as A dash. This axis is marked as A dash. Remove the string, and then what you will do is, you will hang it at point B. Okay, here we have made a hole B. Hang it at the hole B. Again the same thing, extend it, extend the line of action, then you will be getting a straight line, mark it as B dash. Okay, and the center of gravity of the body will be on any point along this line of action, along the straight line B dash. Next what you are going to do, take the third hole, that is C. Okay, take the third hole C. Hang it. After oscillation, it will come to rest. Now, draw a straight line from the string. This is your line of action. Okay, and the center of gravity will be lying on any point on this axis. Okay, now we have 3 lines. Now you will be having A dash. Here you will be having B dash. This is the line. And you will be having C dash. Okay, so these 3 lines, that is the axis we have drawn. We know that center of gravity will be there on any point on these axes. Yes. So when you draw, they will be meeting at a single point, like we have done for a case of a triangle. We have drawn the required medians and these medians are intersected at one point. Similarly here, these 3 lines will intersect at a point. This point is the required center of gravity. Okay, this point will be the center of gravity of this irregular body. For an irregular body, this is how you can find the center of gravity. Even for regular body, you can do this experiment to find center of gravity. If I am making different holes like A, B, C, if I am taking a hole D here, again you will be getting a line that will be passing through the center of gravity. Okay, D dash will be passing through the center of gravity. Okay, this is how to determine the center of gravity for an irregular body. Next topic is uniform circular motion. What is uniform circular motion? First, what is circular motion? If a body is moving along a circular path, then we call it to be in a circular motion. You know what is linear motion? We have studied if this is point A and a boy is moving to point B along a straight line, then this is a linear motion. If it is such that the boy is moving along a circle, then it is a circular motion. Now what is this uniform circular motion? Uniform circular motion is when the boy travels equal distance in equal interval of time. For example, take an object. First, it is at this point. This is point A. Okay. This is point A. Initially, the boy was at point A. In 1 second, what happened is, he shifted to a point B. Okay. Time is 1 second. Time taken is 1 second. He has travelled from A to B. Let the distance travel be 1 meter. Okay. Next, what happened is, from B, he had shifted to C. In 1 second, the distance from B to C is 1 meter. What does this mean? He is travelling equal distance in equal interval of time. In the first 1 second, he had travelled 1 meter. In the second 1 second, he also travelled 1 meter. Next, he shifts to D. Okay, he reaches D. Again 1 second. Okay, in 1 second time, he had travelled 1 meter. In that case, we call it uniform circular motion, travelling equal distance in equal interval of time. If it is uniform linear motion, then what happens? Here, to travel from A to B, first the boy reaches this point in 1 second. Let us say he had travelled 1 meter. Then he reaches this point. Okay, next 1 second he travelled 1 meter. Next 1 second he travelled 1 meter. Again he is travelling equal distance in equal intervals of time. So, understood what the meaning of uniform circular motion is? When a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. What is speed? We know speed is equal to, speed is the ratio of distance and time. Speed is equal to distance by time. Speed is equal to total distance travelled by total time taken. Okay, here what is the speed? In the first 1 second, he travelled 1 meter. Then the speed will be equal to 1 meter per second. Okay, meter per second is the unit of speed. Okay, next, to travel from B to C, he is taking 1 second time and he had travelled 1 meter. Again, when you calculate speed, you will be getting 1 meter per second. Next, C to D, he is taking 1 second to travel 1 meter. Speed is 1 meter per second. So, he has travelled equal distance in equal intervals of time, which means in every case, the speed is remaining same. Therefore, the body is in constant speed or uniform speed. Speed is uniform. Okay, a body in uniform circular motion will have constant speed or uniform speed. Next is velocity is variable or non-uniform velocity. What is velocity? We know velocity is displacement divided by time. Okay. Now here, check this case. The body is traveling distances. But what is the difference? At each point, the direction is different. Velocity is something that depends on magnitude and direction. What do we call such quantities? A quantity which depends on both magnitude and direction is a vector quantity. Velocity is a vector quantity. So here when you check, initially the body was here, okay, at this point. That is, somewhat it is traveling towards the north. It is facing towards the north. When it reaches here, what happens? It is facing or traveling towards the west. Okay, if it reaches here, it is towards the south. If it reaches here, it is towards the east. At this point, it is towards the northeast. So at different point, what is happening? The direction is changing. Since velocity is a quantity which depends on direction, it cannot be calculated just with magnitude. So this is the reason why we say that velocity is variable. Speed and velocity is different. Okay, remember that. Next, direction of motion is along the tangent. So this is the direction of motion. Okay, when you have a circle, or you imagine a case, a stone is tied to a string and it is undergoing a circular motion. Now what happens? Suddenly if you leave the string, what happens? The stone will be moving in a tangential motion along a straight line. From this point, it will move along a straight line, and this is a tangent to the circle. Okay, so here the direction of motion is always along the tangent. Next, it is an accelerated motion. What is acceleration? Acceleration is velocity divided by time, or change in velocity by change in time. When time changes, velocity also changes. Here we know that velocity is not a constant, velocity is not uniform. Therefore, there will be a change in velocity. When you take speed, change in speed will be equal to 0. At this point, the speed was 1 meter per second. At this point, it is 1 meter per second. At this point, it is 1 meter per second. So, change in speed will be equal to 0. But what about change in velocity? Change in velocity, you will be having a definite value. Therefore, when you take change in velocity by change in time, you will always get a value, and hence there is an acceleration. Therefore, uniform circular motion is an accelerated motion. Understood these 4 points? Speed is uniform, velocity is non-uniform, then direction of motion is always along the tangent, and then accelerated motion. Uniform circular motion is an accelerated motion. There is an acceleration. Clear? Direction of velocity at any instant in a circular path. Imagine that you are moving along a circle. Okay, you can move in 2 directions. Either you can move anti-clockwise, that is in this direction, or you can move clockwise in this direction. Okay, so at different instants, you will be having different velocities. As I said, in case of uniform circular motion, speed is same, speed is constant, but velocity is non-uniform. Here, you are considering 4 points. You are moving along the anti-clockwise direction. Then, you are considering 4 points, A, B, C, D. Okay, let us say at point A, your speed is 1 meter per second. At point B, your speed is 1 meter per second. At point C, your speed is 1 meter per second. And at point D, your speed is 1 meter per second. At all the points on the circular path, you are having the same speed, constant speed. But what is the difference? Direction is changing. If you take this point A, when you draw tangent, it is showing towards the north. 1 meter per second towards north. Okay, when you reach as B, here 1 meter per second towards west. What about C? Yes, 1 meter per second towards south. And at point D, it is 1 meter per second towards east. So here we are telling about the velocity. We have both magnitude and the direction. Okay, we have both magnitude and direction. We know that direction of motion is always along the tangent. So you have to draw the tangent drawn at the point of circular path. In the circular path, if I reach this point, if I draw a tangent from here, this is the direction of motion at this point. If I reach this point, if I draw a tangent here, this is the required direction of motion. So at any point, if you draw a tangent, you will be getting the direction of motion. And velocity of a particle in a circular motion is variable, is non-uniform. Or the circular motion is an accelerated motion even though the speed of the particle is uniform. If it is given in the question, you are asked why velocity is variable or while velocity is non-uniform even though speed is uniform. What is the reason? Velocity depends on direction. Okay, at different point on the circle, direction will be different. Therefore, even though speed is same, since velocity depends on direction, there is non-uniform velocity or variable velocity. Clear? Next is the difference between uniform circular motion and uniform linear motion. First, let's consider a linear motion from point A to point B along a straight line if a person is moving. This is his first point. He reaches this point. 1 second, he travelled 1 meter. Okay. Second, this is his point. He again travelled 1 meter in 1 second. This is his third point in 1 second. Next 1 second, he had travelled 1 meter. Next 1 second, he travelled 1 meter to reach B. Now, I'll be marking this as A, B, C. These are my 3 points. For the person to travel from capital A to small a, he has travelled 1 meter distance in 1 second time. Then what is the speed? Speed from A to A will be equal to 1 meter by 1 second. That is 1 meter per second. Now from A to B, what is the speed? Speed to travel from capital A to small b. What is the speed? Here he has travelled, total distance travelled 1 meter plus 1 meter, 2 meter per. 1 second plus 1 second, total time taken, 1 second plus 1 second, what is it? 2 seconds. So cancelling, we will be getting again 1 meter per second. Now if it is from A to C, then 1 meter plus 1 meter plus 1 meter is the total distance travelled, which is 3 meters, and total time taken will be 1 second plus 1 second plus 1 second equal to 3 seconds. 3 meter by 3 seconds, which is equal to 1 meter per second. Constant speed. Okay. So in case of uniform linear motion, there is a constant speed. Now when you come to a circular motion, uniform circular motion, again if you are taking the same case from point A to reach point B. Okay, we are considering 3 points A, B, C. In 1 second, 1 meter. Next 1 second, 1 meter. Next 1 second, 1 meter. Again 1 second, 1 meter. So equal distance travelled in equal time, which means the speed will be constant. Okay, if you calculate first from A to A, 1 meter by 1 second, 1 meter per second. A to B, 1 plus 1, 2, 1 plus 1, 2. 2 meter by 2 second, which is again equal to 1 meter per second. So when you calculate, you are getting constant speed. Next, in case of uniform linear motion, there is constant velocity. We know velocity depends on magnitude and direction. Take this case here, to move from A to small a, he is travelling towards east. Yes. From A to B, again he is travelling towards east. A to C, he is travelling towards east. This, the direction is same. Therefore, since magnitude is same and direction is same, velocity is a constant in case of uniform linear motion. We have discussed in detail about uniform circular motion and why there is variable velocity. At different point, when you draw tangent, you will be getting the direction of motion, and direction of motion is different even though magnitude is same. Therefore, it is having variable velocity or non-uniform velocity. Next, zero acceleration, or this is uniform linear motion is an unaccelerated motion. What is the reason? Since the velocity is constant, we know acceleration is equal to Acceleration is equal to velocity divided by time. Change in velocity by change in time. Here what happens? Here when you take the change in velocity, since there is a constant velocity, change in velocity will be 0. Therefore, 0 acceleration. 0 divided by change in time. Change in time you may get some values, but since the velocity change is 0, we will be getting 0 acceleration. 0 acceleration, such a motion is called unaccelerated motion. Okay. Next is uniform circular motion. Why is uniform circular motion an accelerated motion? Because there is a variable velocity. Change in velocity will have some value. Therefore, acceleration will have a value. It is an accelerated motion. 3 important differences between uniform linear motion and uniform circular motion. Next topic is centripetal force. Okay, these are forces which are experienced in uniform circular motions. Here, what is centripetal force? The force acting on a body moving in a circular path in a direction towards the center of the circular path is called centripetal force. Now, we know that what does force do? We have studied about the effect of force. A force can change the shape of a body, it can change the size, it can change the volume of a body. With that, we have studied few other points. A force can change the direction of motion. A force can bring a body in rest to motion. A body which is at rest can be brought into motion. A force can bring a body in motion to rest. Then, a force can change the direction of motion. Okay. Now, when a body is moving in a circular path, there should be some force to create the velocity to change the direction of motion. If a body is here, there should be some force which is changing its direction of motion. Speed is same. We know that it is in a uniform circular motion, then the speed will be remaining same. Velocity is different. How is this difference in velocity brought? A body can move only when a force is applied. Now, for example, to increase the velocity, in a moving car, you will be applying accelerator. Okay, you will accelerate the car. What happens? The velocity will increase. Now, in order to reduce the speed, you will be applying brakes. Okay, to change velocity, what you are doing? You are applying a force, right? Now, when you consider a body which is in a circular motion, again here in this case, you will have to apply a force to change the velocity. Okay, when there is a change in direction of motion, speed has nothing to do with this. Okay, you have to change the direction of motion. So, direction of motion can be changed only when there is a force. A force is required to change the direction of motion. Only when direction changes, there will be a change in velocity. Okay, when there is a change in direction, it brings a change in velocity. So, there is a non-uniform velocity. When there is a change in velocity, it will be creating an acceleration. Okay, it will be creating an acceleration. So, we understood that only by applying force you can change the direction of motion, then you can change its velocity and then create an accelerated motion. Okay, so this force which creates this change in direction, change in velocity is called centripetal force, and the centripetal force will be always towards the center. Okay, the body is here, centripetal force will be towards the center. If the body reaches here, centripetal force is again towards the center. So, for a body in circular motion, uniform circular motion, centripetal force will always be towards the center. Okay, towards the center of the circle. Understood? The force acting on a body moving in a circular path in a direction towards the center of the circular path is called centripetal force. Clear? Now, we will take some examples for centripetal force. The first example is motion of electron around the nucleus in an atom. We know inside an atom, there is a positively charged nucleus and the electrons are revolving around the nucleus in circular orbits. Okay, this nucleus consists of protons and neutrons. Electrons are revolving in orbits around the nucleus. Now, why don't the electron gets collapsed into the nucleus? What is the reason? There is some force which holds the electrons and helps the electrons to move in the circular path. There is a force of attraction between the positively charged nucleus and the electrons. What do we call this force of attraction? Electrostatic force of attraction. Electrostatic force of attraction. So, this electrostatic force of attraction will help electrons to move around the nucleus in circular orbit. It is creating centripetal force in this case. Okay. So, here the electrostatic force of attraction between the nucleus and the electrons will create the required centripetal force, and this centripetal force will help the electrons to move around the nucleus in circular orbit. So, this is your first example. Clear? Second example, a planet moves around the sun. How does planet move around the sun? Again, planets moves around the sun in circular orbits. Here, the force is the gravitational force of attraction. Okay, there is a gravitational force of attraction between the planets and the sun. This gravitational force of attraction creates the required centripetal force. That is required for this planet to move in circular orbits around the sun. Okay. Here again, what is happening? The gravitational force of attraction is creating the centripetal force, and this centripetal force experienced by the planet towards the center of the sun will help the planet to move in circular orbits around the sun. Clear? Third example is moon moves around the earth. Same as the case of a planet which moves around the sun. When the moon moves around earth, what is happening? There is again a gravitational force of attraction. Okay, here this gravitational force of attraction will create the required centripetal force that helps moon to move around earth in circular orbit. Clear? Okay, this is your third example. Fourth example is the stone which is tied to a string in a uniform circular motion. A stone is taken and it is tied to a string and it is made to move in a uniform circular motion. Here, when the string is left, what happens? The stone will fall down. Okay, that too tangentially. When tangent is drawn, it is the direction of motion. Here, what happens? This string is experiencing a tension. Because of the stone, the string is experiencing a tension. This tension creates centripetal force. Here, it is a tension that creates a centripetal force which helps the stone to go in a uniform circular motion. Okay, here this will be the radius and we have the center where the girl is holding the string will be the center. Okay, now this is the radius and this is the string which is experiencing a tension. Because of this tension, there is a centripetal force experienced by a stone towards its center. Okay, in this direction there will be centripetal force and the centripetal force helps it to move in the uniform circular motion. Okay. Centrifugal force. We have studied about uniform circular motion and centripetal force. This is a continuation of it. A force assumed to be acting on the body in a direction away from the center of circular path. This is called centrifugal force. Another definition is a force assumed by an observer moving with the body to act on the body in a direction away from the center of circular path is called centrifugal force. We have studied that centripetal force is a force experienced by a body towards its center and this force helps the body to move in the circular path. Okay, this is the direction in which centripetal force acts. Now, when it comes to centrifugal force, the force is in the opposite direction. You cannot say that it is on the body, but it is a force that is in opposite direction to the centripetal force. Now, you will be having a doubt. Is this a reaction force? Here, let us take centripetal force as an action force. Is centrifugal force a reaction force of centripetal force? The answer is no. When you take the case of a table and book, okay, a book that is kept on a table. According to Newton's third law of motion, there will be action and reaction force. Book will be applying a force downwards on the table, and the table will be applying a force upwards on the book. Okay, here the force applied by the book on table is the action force, and the force applied by the table on the book is the reaction force, which helps the body to stay. That is, here the book to stay on the table. Yes, so in Newton's third law, it is clear that for every action there is an equal and opposite reaction which acts on two different bodies. Here we have two bodies. Yes, here book is the first body and table is the second body. We have two bodies. Okay, but this is not the case with centripetal and centrifugal force. You have only one body. Clear? Now, the direction of centrifugal force is in opposite to the direction of centripetal force. If centripetal force is inward, then centrifugal force will be outward. Okay. Next point is magnitude is same as that of centripetal force. If centripetal force is of 10 Newton, then centrifugal force will also be of 10 Newton. The only difference is the direction. Okay, direction is different. It is not the reaction of centripetal force. Okay, it is not a reaction force. Now, point to remember is we know that centripetal force is a force that is experienced by a body. Okay, so it is a real force. When it comes to centripetal force, it is a real force. It is experienced by a body. But centrifugal force is assumed, a force assumed to be acting. There is no such force. It is a force that is assumed to be acting. It can be called a virtual force. Okay, it is not a real force. Understood? Let us take an experiment to understand centrifugal force in detail. When we define centrifugal force, we have studied that centrifugal force can be experienced by a body that is moving in the circular path with the other body. Okay, here in a merry-go-round, what is happening? Bodies are in circular motion. You can see that. Okay, now consider you are inside a room in this merry-go-round. Okay, and you are moving along with this bodies in circular path. Here, you are in a room and your position, initial position is A. There is a body at point P. Okay. After some time, what happens is the body shifts to a point P dash. And your position will be A dash. That is, you are rotating with the body. After some time, the body shifts to P double dash and you are rotating again and your position becomes A double dash. Then P triple dash and your position becomes A double dash. So, when you consider this, you will understand that A won't be experiencing, that is a person who is standing at A won't be experiencing that this body is moving because A is moving, that is a person at A is also moving with him. So here when the body was at P, I am at A, so I won't be experiencing that. That is when the body moves, I am also moving. I will be feeling that the body is at rest. Now consider a person who is standing outside this merry-go-round. Okay, he is at a position M which is outside the merry-go-round. What about him? Initially the body was at P. Then the body came to P dash, P double dash, P triple dash. It will be going in a circular path, that is the body is experiencing centripetal force and the body is in uniform circular motion according to M. Okay, according to M, body is in circular motion. Body is in circular motion and the body is experiencing a centripetal force. What about the person at A? He won't be experiencing any force. That is, according to whom there is neither centripetal force nor centrifugal force. But without centripetal force, the body cannot move in circular motion. So there should be some other force which is cancelling the effect of centripetal force. And A, the person at A is feeling that the body is at rest. This is actually relative. Consider the motion of a body inside a train. Okay, for a person who is sitting inside the train, the opposite person, he will be feeling like the opposite person is not moving. But a person who is standing in the platform will feel that both the persons are moving. Okay, it is relative, right? So here again this is also relative. For M, the body is in circular motion. But a person standing at A the body at P is not moving. The body is at rest. The reason what he gives is, here there should be some other force which is cancelling the effect. We know that centripetal force is a real force. Without centripetal force, the body cannot move in circular motion. Okay, there should be some force which is cancelling the effect, and this force is a centrifugal force. Centrifugal force. To cancel the effect of centripetal force, it is acting, and hence this is actually an assumed force. It is an assumed force which is experienced only by a person at point A. Okay, that is a person, an observer who is moving along with the body in a circular motion. Clear? So this is the case. Now consider another case when suddenly the string breaks. So a body is in circular motion because there is a tension created by the string. Okay, consider the case with a girl who is holding a string and a stone is tied to it. Okay, girl is standing in the center and it is the body, that is the stone, is moving in a circular motion. Suddenly what happens when the string breaks? How does it move? How does the stone move then? It will be moving in a tangential motion, right? For a body, that is a person who is standing outside this, okay, outside the frame, will be observing the body is moving in a straight line. Initially, it was at P. Suddenly when the string breaks, it shifts to P dash, then P double dash, P triple dash, then at some point T it falls. Okay, so PT, a straight line motion is experienced by M who is standing outside. Okay, what about A? Now tell me, what about A? A is in the center. Okay, we know that A is moving along with P when it was in circular motion. Okay, so when initially the body was at P, A was able to observe. At A dash, it was able to observe. Even if the string breaks, still A is able to observe the body at P. Okay, initially it was at P, and when the body at A shifts, that is when it comes to A dash, the body is still there at P dash, it is able to observe. But a body who is standing, or a person who is standing at A, won't be able to see either it in a circular motion or in a straight line motion, but still is able to see the body. He will be experiencing like the body is moving away from him. Okay, that is the body is moving away from him. This is the only difference. In the first case, how was it? The body and he was moving together, which means he is feeling that there is no effect, that is the body is at rest. Now what happens? Here he is experiencing like the body is moving away from him. Okay, now here there is the centripetal force is being cancelled. Yes, so here what the explanation given is, when the body is moving away from him, it is actually due to the effect of centrifugal force. Okay, this centrifugal force, centripetal force was controlling it and that is the body was able to move in a circular motion because of the centripetal force. So suddenly when the string breaks, what happens? The centripetal force is cancelled and the body is moving in a straight line motion. Tangentially, with the same velocity, it will continue to move. Okay, here what A experiences is the body at A will be experiencing like the body at the point P after the string breaks will be moving away from him. Neither it is in circular motion, neither it is in rest or in straight line motion. It is just experiencing like the body is moving away from him, and that is the body is pushed away from him due to the centrifugal force. Okay, so just understand this point. Centrifugal force will always be experienced by a body which is moving along with a body which is in circular motion. Clear? So here we have given the explanation how the centrifugal force will be experienced by a body that is moving with the body in circular motion. Clear? Two cases we have taken. Initially when the body at A is experiencing, the body at P is in, that is the body in circular motion is in rest. Okay. The second case is after the string breaks, the body is moving away from him. Fine. We have studied two forces in a circular moving body. What are the two forces? Centripetal force and centrifugal force. Main difference between Centripetal force and centrifugal force are, first one, acts towards the center. Centripetal force will act always towards the center. What about centrifugal force? Centrifugal force will act away from the center, opposite direction. Okay. Then centripetal force is a real force. We are experiencing centripetal force. What about centrifugal force? It is a virtual force. It is assumed. Okay. It is actually assumed. There is no such force, or it can be called a virtual force. Clear? That's all for today. In today's class, we have discussed about center of gravity, uniform circular motion, and centripetal force, centrifugal force. Hope you all have understood these topics. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.